like and leave a heart, please.
There we go. Hello and welcome to the Vidor Locksmith Show, where we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, and one technical screw up at a time. So happy you guys are here with us on this Friday, and I'm going to try not to hit the desk too much because it shakes the camera, even though I've been doing this for quite some time and I still forget that. We have got an absolutely amazing show for you guys today. Really excited about it. I say that every week, but I really do mean it. Love to be able to see anybody that comments. First of all, let me know where you guys are watching from. Always love to be able to give everybody a shout out here on the show. If anybody was at the IADD Mud Motor Forum yesterday in Houston, give us a shout out as well. It was an absolutely amazing event. Our first big technical event since pre-COVID. And it was the largest IADD forum event ever. Right, we had over 300 something people be able to show up. 270 something people showed up. Another 30 plus that showed up the day of. So absolutely amazing event. Lots of information. Lots of people talking about mud motors and power sections and lower ends. It was really, really, really good event. It was great to be able to see a lot of people there yesterday as well. So give me a shout. Let me know if you guys were there as well. Trying to think. Finished up episode number 3 of the Torque and Drag series. Where's my paper? I put it somewhere. Hold on. Maybe it's over here. There it is. There we go. So yeah, finished up episode number 3 this week with Dr. C, where we did basic physics. Next week on Tuesday, we've got Dr. Stéphane Menon from HMP Technology, not HMP Technologies, from HMP. It used to be called HMP Technology. It used to be Drill Scan, still the Drill Scan software. Anyways, he's coming on Tuesday to be able to talk about the soft string versus stiff string models. If you do not know what that is and you are in the drilling industry, then you should probably tune in to be able to learn about it. Then we've got 4 more episodes after that. So be sure to check out the Torque and Drag mini series. Lots of great stuff going on there. We've had tons of people tuning in, watching it. Lots of operators who are requiring a lot of their junior engineers to watch the program as a whole, and then even potentially putting it onto their like learning systems, internal learning systems. So lots to be able to learn there. It's completely free here on LinkedIn, YouTube, Facebook, wherever you guys like to be able to watch. All right, we'll go through some of the comments real quick. Say hi to everybody. So Eric tuned in from sunny south of France, of course. We got Artie Morrison. Artie, thanks for being here, man. Damon says good morning. Thanks for being here, sir. Slim tuned in from Algeria. Sean from Scotland. Robert tuned in from the Netherlands. Thanks for being here. Zaid, who is working on his thesis. So if you guys have any good ideas, be sure to give him a shout. Let him know. Jeff Chestnut tuning in. Damon says he's tuned in from the Woodlands. Thanks. Arsalan Amer tuning in from Pakistan. Thanks for being here, sir. Mr. John DeWart tuning in from Colorado. Thank you. And Hassan tuning in says hello from Abu Dhabi. All right, quite the international audience. Once again, thank you guys so much for tuning in. Like, share, subscribe, tag somebody in the comment section. Like I said, we've got an absolutely amazing show today. So, as per normal, if you'd like to win a drill bit, gave away a couple of these yesterday. If you want to win a drill bit, just put in, let's say, hashtag Gibson. So that'll be the code for today. We'll give this away probably towards the end of the show. So do that. Put in hashtag Gibson through now and throughout the show. We'll do the drawing later in the show, but just want to be able to let you guys know. So do that. Other quick news. I will be at NAPE on Thursday next week. So if you're attending NAPE and you want to be able to come by and say hi, come say hi. I will be there. Maybe I'll bring a couple of drill bits with me so they do little giveaways and stuff. I think a couple of people have already put it in. There we go. There we go. Hashtag Gibson. That's all you got to do. Click that one. Cruz, who was on the show last week, says, when do we get green ones? I'll get some green ones printed. Promise you that. Maybe Tracy, if you'll remind me to buy a couple of buy some green filament. If you were in the oil and gas industry on the drilling side and you want to learn anything about whipstocks, Last Friday was the master class for Whipstocks with Crews. He did an absolutely phenomenal job. Light bulb moments for me the entire time we're going off. It's an absolutely amazing show. So go check that out. Obviously on LinkedIn. Obviously, go back and check it out on YouTube as well. So if you want to learn anything about Whipstocks, there it is. All right. I don't know if we've got anything else to be able to share or any things. So we'll get on with the show. So today, welcoming to the show, we're doing this a little bit different than what we've done in the past. So we're going to be standing up this time, kind of like what we did with Cruise, but not just for a presentation. Oops, click the wrong button. Oh, that camera's off. Okay, hold on just a second, guys. Never mind. Hold on just a second. We'll let this GoPro boot up. We're building the intensity. There it goes. Now we got it turned on. All right. We'll have to give it just a second. There's our technical screw up for the day. No big deal. We planned for this. We knew things were going to happen. It's quite all right. And let's see. There it is. Travis Harris from Allamon Tool Company. Travis, thanks for being on the show, man. Appreciate it.
Thanks for having me here. I'm very excited. Appreciate the invite.
All right, guys. So Travis is going to be talking to us about all kinds of things. Specifically, we're going to be looking at a lot of stuff around casing liner hangers. So if you guys have any questions in that area, I'm looking at the totally wrong camera. So if you guys have any questions in that area, please be sure to start throwing them out. But yeah, let's jump into it. So give us a little bit about your background, Travis.
So been in the oil and gas industry for over 35 years. Started in 1986 with a little company out over in East Texas called Mustang Drilling. So I have a drilling background. Spent a big chunk of my career at Baker Hughes. And then left there in the last 7-8 years was at a company called Packers Plus, where we designed a whole new line of cemented products. Recently left there and purchased Allamon Tool Company with an investor. And Allamon, I think a lot of people, if you know who Allamon Tool Company was, you knew Jerry Allamon. So he was an amazing guy, 20-year business. But he got sick a couple of years ago and passed away. The family didn't want to keep the business. So we stepped in, purchased it, and amazing tools, great products. And so we've had a really fun time growing this business and bringing it to a new level. So that's kind of a short rundown of my background. So.
All right. Well, like I said, I don't know. Do you know Andrew Quinlan? He says, good to see you, Travis.
Oh, I do know Mr. Quinlan.
Oh, all right.
So,
all right.
Electrical engineer, very smart guy.
He is a very smart guy. Very smart guy. Okay, so tell me a little bit about as far as your background. Like, how did you go from doing some of the drilling stuff to getting over towards more completion tools?
So was always a drilling guy. Went to work for Baker back in the late 90s, early 2000s, and moved over into the completion industry, which I knew nothing about. So
I know nothing about, so it's gonna be hard to ask questions about.
When you're a drilling guy and they come out to run a pack or a hanger, that's when you always go take a smoke break, right? So never paid attention, but was able to have some great people that taught me a lot over Baker. So I became a completions guy, moved into operations, and had a great career over there, enjoyed working there. And then just kind of evolved from that into the cemented side of the business. So worked a lot with the open hole, of course, with Packers Plus and some of the design stuff on that. So as I just continued to grow and learn in the industry, had a good friend that got me over at Packers to help start a new liner hanger product. So we actually built a whole new portfolio of liner hanger systems that they deploy in the Middle East now. So high pressure, high temperature type systems. So really it was, in this industry, as you're designing and developing, it's a learn as you go, right? So we were just continually learning. So now I'm over at Allamon, amazing line of tools, just making them better all the time. So liner hangers is one of those things, there's always something to improve or get better. It's an always evolving system. So these tools have been around a while, but they're very proven and very traditional. So I'm excited to talk a little bit about that, because if you're not in the drilling or completion liner hanger market, a lot of people don't know what a liner hanger is. They don't know what it does or understand. So I hope today I can enlighten people. We'll stay high level, but I can kind of show people how these tools work and what the benefits are to them.
What would you say is the best way to first introduce, somebody who's been on the drilling side to liner hangers and that side of the business?
So, the only way I've always thought to learn it is to go out and get on a job, right? So, understanding how these tools are assembled and stabbed up in the shop is very important. Seeing the functionality of the tools, but getting out on a job and actually watching these tools go down and see what these service hands do, because they're amazing. And you're only as good as your tool hands, right? So our service tool hands are amazing in the industry. And if you want to learn how to do that, get out there and see that. Because there's a lot of math. You guys been doing the torque and drag show. Wow. That's so amazing, because it's so important to understand all the hydraulics that are going on downhole when you deploy these systems. And every well is a little different. So I think that's great. But again, just getting hands-on out in the field is, I've always thought that's the best way to learn. And when we train people, we get them out in the field. They need to see how these things go downhole.
So you talk about training. So how long is, like, if you hire somebody to be, what would you call them? Like a liner hand? Or?
Well, we call them service hands or tool hands.
Tool hands.
Yeah.
So how long is that training process? Like, if you get somebody, no industry experience from fresh, and you get them up to where I would guess you would say running their own jobs or doing their own call outs.
Yeah, it takes a while. So yeah, it's packers and production type tools are a lot simpler or a lot easier because the pressure's not there. But when you're on a drilling rig and it's, now it's $25,000-$30,000 a day, there's a lot at stake. If you do them offshore, it's even more. But yes, I would say from the start to getting somebody where they break out on their own, it's going to take a while, more than a year. If they've got experience, they might move a little faster. Sometimes it can take a year and a half to get somebody up to speed from, we would immediately put them out in the shop where they would be warehousing and redressing the tools so they can learn the tools, understand it. They need to understand all their hydraulics. Then they need to go out in the field and be trained by, one of our service guys that does training. And it's just a repetitive process, but it takes a while. It's not something that happens overnight. And I can tell you, our tool hands, I don't think we have a guy on the payroll that's got less than 15 years. So
oh my gosh,
it takes, a long time to be very competent in this job. Anytime you're dealing with cement and tools in a hole, you can't just stop and go make phone calls. You have to have the capability to know what to do. So it does take a while. So and we're very fortunate that we have such a great set of service tool guys that handle our work for us.
I mean, that's extremely impressive to have that level of seniority is that like the upper echelon of like the position to be able to kind of work into?
Oh, definitely. These guys, they get well rewarded for their work. It's tough work. They spend a lot of time on location, but it's very rewarding financially for them. So, like I said, we've been very blessed, very lucky to have such a great group of guys. And, as we grow and, we're always trying to bring up that next person, get them trained. So we got guys in queue all the time, but so far we've been, since COVID, we've been very fortunate to have this really, really mature, very skilled set of guys that deploy these tools for us.
How are you guys doing that now? Because I know a lot of people have had employee shortages and difficulties there. How do you guys always keep that kind of queue fed to make sure that you've got guys that are always coming up?
That's very, very good question. And in the Midland Basin, the Permian, where we have a big chunk of our work, warehousemen and tool hands are a valued resource, right? So culture is the first thing, right? We want to make sure that these guys, we listen to what they need. We take care of them that way. Financially is important. So, making sure these guys are well taken care of with good vehicles, good tools, good support, especially from the engineering and operations side. Those things are really important to keep these guys happy. So, it's ongoing. I'm a huge culture guy, right? So I want people to really love working for the company they're at. And we do that by doing the things I mentioned, so, but yes, they're a valued resource. We're always looking for that next great guy that we can bring in and get trained up.
How long does a typical job last?
So deploying hanger, Permian Basin or a Bakken or DJ well, you're usually on location anywhere from 24 to 36 hours. If they have any kind of hole condition problems, sometimes you can be 48. We have some 60-hour jobs, so they're very taxing. It's a different lifestyle being a service hand out there. So these guys are tough, man. They spend a lot of time in their truck. They spend a lot of time on that rig floor. So it's and a lot of sleep deprivation, right? So the good guys know when to get sleep. And just like offshore, you got to know when to catch that nap. But they do a good job at managing that. So, and we have a really good efficiency program. So we don't want to overwork these guys because they have families, they have children and lives. So we try to work that efficiency where these guys get time off to spend with their families. That's really important with the culture.
So do they usually go from one job to the next, or is it, you know, you get the call out, you go do that one, and then you come back, and then you're waiting for the next call out? Because I mean, obviously that sounds like something fairly difficult to be able to schedule any kind of routine.
Oh man, you're absolutely correct. So we have some amazing coordinators in our Midland office. They direct the bulk of our service guys. But yes, you typically come off a job, you get some days off, you get to rest. One thing that we do, back to that culture, is we don't require our service hands to live in the area they work in. So we got guys in Louisiana, we got guys in Oklahoma, all over the place. So they're allowed to go home, spend time with their family, and then come back. So, but it is a ongoing battle, always working with the rigs, trying to schedule each job, because sometimes rigs drill faster, sometimes they have problems. But we do a great job at keeping that schedule going all the time. So we have a huge job board that's live, and it's an active job board that's changing every day. So the guys are just staying in queue and rotation all the time. And then you got guys, you know, there's always somebody who wants vacation, right? So you got to plan all that in there. But our guys out in Midland do a great job.
And then you get random call outs for new jobs.
Absolutely. You know, we get an emergency job calls in where it's not on the board, so we have to be able to react to that. So yeah, it's always an ongoing challenge to make sure these guys get time off. But typically they don't go from job to job. When they get finished with the job, they get to stage out. So we have some places that these guys can go after the job in Midland and get rest. They, you know, get a room. They can cook, they got barbecue pit, they can rest, and then they can go home, or they can stay there and rest for the next queue job that comes up.
Wow. I mean, it's like, I know we were talking about it before the show, but it's, you know, one of those things to where, like, you know, the drilling guys, it's like, as soon as we kind of like TD or whatever, or they, you know, break the bit and lay down BHA, then I'm like, all right, I'm out of here. And then like, there's this whole other side of the business and everything else that takes place. And it's like, completely miss all of that, but that's everybody else kind of coming in. So I could understand how difficult it would be to be able to schedule that, because, you know, numerous times I've been on the rig and it's like, hey, when are you going to be done? And it's like, oh, you know, we'll be done in, you know, 2 or 3 days, and then 2 or 3 days turns into 2 or 3 weeks. So
yeah,
you know, there's other part of the operations that you guys are following with that. So I'm guessing that's probably one of the biggest things for you guys is that scheduling board.
Absolutely. And you know, like you said, you know, they say they'll call for tools, they'll call for a hand, and then all of a sudden they got to make a last minute bit trip, right? So, you know, there's 24, 36 hours, but our guys are out there on location waiting. We're always usually ahead of the game, so our tools are always out there early, because we're talking to those rig guys every single day. So, and we're always in that queue rotation. You know, the other thing is that our guys get really familiar with how each rig performs. And they know this rig drills faster, this rig doesn't, you know, so they understand those things. So when they're talking, we're always scheduling ahead of time. So it is a challenge though. And this is where people are so important, because we have guys that do such a great job at making sure that all that's taken care of. And those are things behind the scene that people don't see, right? Like you said, you don't see all that stuff.
Yeah. So is it usually that, like, you know, you might have like one crew or one, is it like a crew that goes out there? How many people are out there on the job?
Typically one guy per job. So unless we have somebody training, or we have a new tool, or some iteration of a new tool, we might send an engineer out with it. But typically it's one guy per job.
So does that one guy usually just follow one specific rig to where he's got that one, or do they have, like, you know, 2 or 3 rigs?
No, we try to float our guys around. So, you know, because
so they get to see all of them.
Yeah. Okay. So we try to rotate. So we're very fortunate that we have a very high skilled group of guys, so they can do any job for any client that we have out there. So typically they don't get the same guy every time. Some of the rigs like to have the same guy because they get comfortable, but we like to mix it up, so they're always getting a new guy or the same or a different person. But one thing we work real hard to do is that no matter who's out there, everything goes exactly the same. We do the same exact process every single time. So, and that's very important, right? So that everybody's on the same page doing the same thing.
So how do y'all do that when you know that, like, some rigs are going to have, ST80s, some are going to have, SD120s or just chain tongs or, Kelly driven rigs? Like, how do you guys set it up to where you're doing the same procedure every time, but like the equipment and the environment can be completely different?
So that can be a challenge sometimes, because a lot of times when we run a cement head, you might space out 8 foot off the floor. We got some rig companies that will not let anybody but their hands go up to actuate the cement head. So you get those kind of things. So we have to adjust to those things. The ST80s, we were just talking about a top drive versus a Kelly rig. So there's a lot of changes mechanically there. But when we run these tools and we set them, the speed we run, the way we drop the ball, the way we pump on it, the way we manipulate the tools, we try to make that the same every single time. So it doesn't matter if it's a Kelly rig, if it's a top drive rig, if we're setting with a pump truck versus the rig pumps, we try to do the exact same thing every time. So you always have little iterations, but we really try to stay away from what we call MOC, right? Management of change. We try to do the same thing every time. So that's, I think, a key to success, right? If you're doing the same thing every single time and everybody's on that page, things seem to go better.
So as far as talking about this culture and doing this, is this something that y'all did on your initial implementation when you guys purchased the company and came in?
So yeah, we did a little bit, but Allamon already did a great job. So Allamon Tools, and they had some really good tool hands. We brought some guys over from our former job, and we implemented those guys in. So it was it was kind of a mesh of two, but the good thing, Allamon has a great reputation. They've been around for 20 years. They've had hangars for over 12 years, thousands of runs. They were kind of always known for their quality and for their work excellence, operational excellence. So we just kind of embedded that into what we do. So our core values, the top one is operational excellence. I mean, we have to be not perfect, but excellent, right? Because you always want to get better. If you try to be perfect and you don't, and you're not, you fail. But if you're always working towards excellence, you're always trying to get better. So that's a key core value for us. And then client intimacy, right? So we want to be in those relationships with these operators that that they can pick up the phone and call anybody in the company. So we really work hard to that. And the last part's that innovation, and it's not necessarily tools with innovation. Sometimes it's efficiencies and doing the same thing every time. We really work really hard to make all that on the same level so that it ensures a success for us.
So what really prompted you to want to go after and be able to buy the company? Obviously there's, the passing of the previous owner, but what was it that we were like, oh, this is something I really want to be able to do?
So that's a great question, because I don't know anything else, right? So when the old adage is, when you fail at everything else, we go back to the wolf field, right? But no, I do have a huge passion for completions, for actually liner hangers. The last 10 years, I've just really enjoyed designing and developing those things and implementing. So, when I saw that Allamon was up for sale, knowing their history, knowing Jerry, knowing how great their tools were, I got really excited about that. And was very fortunate to have a great investor that saw the value in that. And now we've got some money behind this company so we can really grow it to a truly global level. So that's kind of our drive behind it. But that's my passion, right? So
yeah. So what was one of the biggest learning moments for you after kind of assuming the position of the leadership role for the company?
So, it's not fun at the top sometimes, and I'm not at the top. I'm a team player, so we're all on the same team. I always feel that way. But when the buck stops with you, if something goes wrong, there's nobody to say it's somebody else's fault. It's always on you. But I am a huge team player. in our organization, I don't see myself as the czar of the company. We're all on the same team. We all work together on the same team. So that's really important to me. But yeah, it's when there's nobody else, when you make a decision or when your team makes a decision, it really falls back on you. Did we make the right decision? Did we do the right thing? Especially when you're chasing markets and deciding on innovation like a new tool. There's a lot riding on that. So, and there's nobody above you to say, oh, it's their fault. So that's probably the hardest part.
Have you been enjoying it so far?
I absolutely love it. I love it. Challenges, lots of challenges, but yes, I love the industry. And, we're a liner hanger company. We do other things. We do open hole completions and wet shoes and toe sleeves and all the things that go with it. But at our core, we're a liner hanger company, and we chase drilling rigs. There is not a more unstable industry on the planet, I don't think. So right now it's good, right? We see it's good now, but you know how this industry is. So it's a highly volatile industry. Fast-paced, fast-moving.
That's the addiction that keeps us all coming back.
Man, absolutely. I love it, right? So every day you're looking at the markets and, trying to figure out what's going to happen next. But right now it's good. So everybody's happy.
Well, you say you're a liner hanger company. Let's jump in. Let's do the presentation. Why don't you give us a little bit of or if you want to do a quick introduction before, tell us a little bit about what are liner hangers, because I'd love to be able to ask you more questions, but I still don't.
Okay.
I still don't know.
No, let's jump in, because the first thing is if you're not in this part of the industry, most people don't know what a liner hanger is. So go ahead. We'll get that up.
There we go. Here, if you want to stand, you can stand right here. And
yeah, you want to switch, please?
Yeah.
Okay.
Here, we'll even switch the camera so it's all you right there.
Oh yeah.
And then I'll click on this, and then you should be able to
just down arrow key, take me to the next slide. There we go.
There we go.
Okay. So what I want to do today is I want to get a little technical, but I want to try to stay as high level as possible. So the first thing is, what is a liner hanger? A lot of people don't really understand what this tool is. What is a liner hanger? Why would you run a liner hanger? And then how does a liner hanger work? So the first thing, and what I want to talk to you, there's a couple of different types of liner hangers out there. There's drill down hangers and there's production hangers. What I like to do today is just kind of stay on the production hanger side, so I can kind of show you guys or just go through a high level iteration of how that works. So what is a liner hanger? So a liner hanger is really two tools in one. So if you can see there on the right, the green tool. So on the bottom, you have these pocket style slips, and that's your hanger part. So what a liner hanger does is it hangs your production casing inside of your intermediate casing. And then the second part of it is there's a packer there on top. So it's a hanger and a packer combined into one tool. So what the packer does is it gives you isolation between your intermediate casing and your production casing. So that's what a liner hanger is. And why would you want to run a liner hanger? So I'll show you this wellbore diagram. So what's the benefits to run a hanger? So this is a pretty traditional 4-string hookup. You've got 9 5/8 intermediate casing, and then you have a 7-inch production liner at the bottom. So if you see right up there at the top where the 7-inch stops inside of the 9 5/8, that's where your liner hanger would go. So you would hang that 7-inch off, you would isolate with a packer in the intermediate, and then you don't have to run that production casing all the way back to surface. So what does that mean to the operator? So instead of, most wells in Permian Basin, Bakken, they're going to have 10 to 11,000 foot TVDs, right? So you're saving that 10 to 11,000 foot of casing back to surface. So what does that equate to? So in a 4.5 by 7 or a 7 by 9 5/8, 5 by 7, whatever it might be, you're basically, the operator's saving somewhere between $500,000 and $750,000 on their AFE. So they're not having to run that casing all the way back to surface. So that's the value add for a liner hanger. Now there's a lot of other benefits it brings that we can talk to, and it gives you options. But so that's kind of how a liner hanger, what it does and what the benefits are to it. So let's talk about a little bit about a production liner hanger. So when would you deploy a production style liner hanger? So typically when the rigs finish drilling the well, you were just talking about that, when they TD and they finish the well, they're going to pick up casing, the production casing. So they'll run the production casing out. And nowadays, most of these are horizontal wells. So they'll run that production casing. And at the very top of it, they will put the liner hanger with the running tool, which is connected to the drill pipe. So they will deploy all that down the wellbore all the way to the measured depth of the well. And then the hanger will overlap up into the intermediate casing. So that's how they're deployed. And most hangers are always cemented in the wellbore. So, you know, plug and perf is probably 94, 95% of the completion method in the US. There's still open hole and other ways to complete, but most of the time these tools are cemented in. So, and then the last thing, most of your production hangers are designed to withstand the stimulation or the frack, right? So these tools have to have high pressure ratings, burst, collapse, differential pressure ratings, because they're going to be taking the brunt of the frack when they're stimulating these jobs over and over. So just a couple of things about the tools. So they're not like a aftermarket production tool or a refract tool or something like that. They have to be able to handle some high treating pressures. So here is,
oh my gosh,
a cross section. This is what we call our layout drawing. This is our standard 4.5 by 7 liner hanger system. On the top, you see the hanger. On the bottom, you see the running tool. So let me just kind of go through how this hanger system would work, and I'm just going to talk through it. So basically what would happen is the rig would pick up that casing. They're going to deploy it to bottom. Once they've reached depth and you're ready to set the liner hanger, we're going to drop a ball from surface. So in this running tool that is stabbed up into the liner hanger, there's 2 ball seats. So we're going to pump the ball down. It's going to land on the first seat. And when it lands on that seat, you're going to see about a 12 to 1500 PSI differential pressure. So you'll see a little spike and the ball will extrude to that seat. And we have a sleeve in this running tool that will shift up. That unlocks the running tool. So now the running tool can engage on the hanger. So when we want to release it, we can mechanically release it. And let me back up and just say something. This tool is traditionally, it's a hydraulic set, mechanically released tool. So that's pretty traditional in the liner hanger world. There's all different iterations. You got hydraulic set, hydraulic release. You've got all kinds of different ways to do it. This is a very traditional hydraulic set, mechanical release. So
let me interrupt just real quick, just because
the
MWD side of me always has to ask about electronics. Are there any that do this electronically?
Not really. You got expandables in the market, but most of that is all hydraulically controlled. So
it's like some kind of mechanical.
Yeah, mechanical, hydraulic, manipulation to get these tools to set. To my knowledge, there's not anything out there. There's a lot of packers and systems that are electronically, that you can pulsate through the fluid and all different kinds of ways. But no, these are traditionally hydraulically, mechanically manipulated to make them actual.
Okay.
So great question.
Just random question from me there.
No, great question. So now we unlock the tool. The ball will extrude and go down about 6 feet onto the setting seat, which actually sets the hanger. So we will pressure up 2,500 PSI. And because we create a differential, those pocket style slips on the hanger will hydraulically set. They'll reach out and touch the intermediate casing. So then we'll slack off and we'll see we lost all that production casing weight. So we know the hanger's set. So at this point now the tool's unlocked. So we will manipulate at surface. We'll turn to the right and we'll release the running tool off of the hanger. So once we release off, we'll pick up about 6 feet and we'll see we lost that weight, right? So we pick up 6 feet and now we're ready. The running tool will still be inside of the polished bore receptacle. And I'll talk a little bit more about that in a minute, but now we're ready to cement the job. So now they'll rig up cement at surface and they will pump cement down the drill pipe, through the running tool, through the hanger, all the way down the casing, up the annular side. So now we're pumping cement between the production casing and the formation wall. That's the isolation they want when they do their plug and perf.
Yep.
They'll bring that cement all the way back up into the intermediate casing, and most times they bring it up above our running tool and PBR into the vertical section. So behind that cement, we will launch a dart, a wiper dart, and that dart will pump down and it will wipe all the excess stringers of cement and all that all the way down the drill pipe, out the casing, all the way to the toe of the well. And we have what we call a landing collar. So the plug will latch into that landing collar, and that's what we call a plug bump. So we're displacing all this cement, and then all of a sudden we'll get that pressure when that plug bumps, and we know we've displaced. So once they bump the plug, now they're ready to set the packer. So we will, again, manipulate the pipe up. We'll pick up a couple of more feet, and on the top of the running tool, and I'll show you this in a second, we have a collet that pops out. So now that collet pops out. Now we set down on top of the PBR, and we force, mechanically wise, that packer to set. And it's a very standard packer. It has a cone on it. So it's like turning a sock inside out. So you're pushing down, and the cones are pushing the element out, and the element comes out and contacts the intermediate casing wall. That's your seal that gives you isolation along with the cement between your production casing and your intermediate casing. So once we set that packer, then we'll do what they traditionally call a negative test or a backside test. So now they'll pressure down the backside of the drill pipe against that packer and cement and make sure they get a good seal in a hole. So they'll hold that. Once that's done, then they'll circulate out the excess cement that's above us and displace that with completion fluid. Then they'll trip the running tools out of the hole, and the well is now ready to be fracked. So that's basically the process of how a liner hanger works. It's pretty high level. There's a lot of little things that go on in there. But overall, what you're doing is you're cementing up that production casing and putting a sheath of cement between between the formation and the casing. So when they perforate, they get isolation. So the perf's not going up and down the pipe, it's going out into the formation.
And so obviously then they'd be able to pull the packer out when it's time.
No, the packer, this tool stays in the hole. It's designed to never come out. So once you've released off the tool and you come out of the hole, now you've got, and let me just show you. So now this is what you would have looking at you. The PBR, the polished bore receptacle, is that long piece on top. So that is looking up into the wellbore, and that's going to be the same dimensions as your production casing. So what that PBR allows you to do is at any time in the future, if you have any kind of problems with your intermediate casing, i.e. a leak or some kind of problem, you can run back in the wellbore with production casing and a seal stack, and what we call a floating seal stack, and they will sting into that PBR. So now you can produce up the, if it was 4.5, you could produce up the 4.5 casing. If it's 7-inch, you produce up that. So you're not producing up your intermediate. So it's a nice advantage for the life of the wellbore, or anytime they want to re-stimulate or refract, they might want to go in with the work string and stab into that. So it gives you options there.
Okay.
So basically, that's what the hanger would look like going into the wellbore. I know a lot of these diagrams don't show the PBR on top. A PBR can be 10 feet, can be 20 feet. We even do 30 foot. And all that depends on your tube move, right? So the true vertical depth of the well, the temperature, and they do a tube move on pipe manipulation. How much, when you shut the well in and open the well when it's heating and cooling, how much does the pipe stretch? So you know how long to put that PBR in there for those seals to ride.
Excellent.
Yeah, so
learning a lot here today.
Yeah. So I told you it was pretty technical, but
hey, that's what we like. That's what the audience likes as well. So
you can see here, you got your packer, your liner top packer. You've got your hold down slips below the packer. So basically, they hold up, so the tool can't go up. And then your hanger pocket style slips on the bottom are facing, the wickers are down, so they're holding down. So when this system's set, it's truly a bidirectional system. It can't go up or down, so it's locked into place. And then you have your cylinder on the bottom, which is your hydraulic portion to set your hanger. So let's talk a little bit. So really the heart of this tool, so hydraulic set, mechanically released tool. So the heart of this tool is really your running tool. So that's where all the cool stuff happens. That's where all the manipulation happens. So basically, we have three components. We have a packer setting tool that you heard me talk about. We've got the running or the run-in tool, which is really the beast that does all the work. And then you've got your swab cup assembly on the bottom to create your isolation. So just a high-level overview. Here's your packer setting tool. It's on the very top of the running tool that's stabbed in through the hanger. So once we get our cement done, we bumped our plug. Now we're going to pick on up. We're released off the hanger, and the packer setting tool will come out, and you can see that red collet there. That collet will pop out, and on top of this PBR here, on the very top of that PBR, that collet will sit down on top, and then we will put about 50,000 pounds down, and that will shear the packer, and now we push that element out to create that isolation. So that's how that works. One really cool thing about this tool is that we have a secondary shear that when we're setting down, it shears, and it's kind of like a hammer, and it gives you a really nice bobble that you will see on the weight indicator. A lot of times you even feel it on the rig floor. So it's a really strong indicator that you've set your packer. So that's a nice feature, because when you're pushing down on the pipe, you don't know if you set anything or not. But if you get that nice bobble on the weight indicator and you feel it, you're pretty confident you've set your packer. So the next part of the running tool is the heart of it. This is where most of the work is done. So this is the running tool. It's in the center of the whole hookup, and it has a couple of parts. So the first thing, it has the torque ring, and the torque ring is what carries all the weight of all that pipe below you when you're going in the hole. So when the tool's stabbed up, that torque ring is holding all of that casing going down hole as you're deploying. So then you have torque keys, and the torque keys on the top of the hanger, we have some castellations, and these torque keys lock into those castellations. So as you're pushing all of this out, and everybody knows today that we do 20,000 measured depth wells, 25,000 measured depth wells all the time. So you're trying to push all of this pipe, drill pipe, casing, all the way to bottom, and sometimes it gets very difficult. We've got deviations, ledges, so you might need to rotate this thing. So those torque keys allow you to lock in, and you can turn that whole liner system with all that casing to rotate it to bottom.
Oh, wow. So
yeah, and we do this all the time now. So they drill these wells so very fast, and I know you're a directional guy by trade, but we tend to see lots of deviations. I wish you guys could drill a straight hole.
So obviously torque and drag matters to you guys as well.
Absolutely. We run torque and drags every day. We run 2 moves and torque and drags. We have our engineers do that every single day. So yes, very important, because we need to know what kind of force we're going to get down. Now there's all kinds of devices that we can use to lighten the load, float in subs where we evacuate the casing below to lighten it up, to give you buoyancy, to help us push it down. So there's different ways you can manipulate that stuff. But at the end of the day, the longer these wells are, the faster we drill these wells. You get ledges and corkscrews and deviations. A lot of times we have to rotate these systems to get them to bottom. So just that's a major part of this running tool. And then the 2 other pieces, you got the float nut on the bottom. So that nut is what is engaged onto the running tool. So, I mentioned that the running tool's in the lock position going in until we drop that ball. But when we unlock it, that float nut is what we turn to disengage us from the liner hanger in the running tool. And then the last part of this is that pack off on the top. So it's a bonded seal that we run. And so when we pick up after we release and we're up in the PBR, we need to be sealed, right? Because when we're doing those tests on the packer, when we're pumping fluid, we don't want to be leaking into the tubing. So that bonded seal is very important. And that seal provides us a non-leak path through the tubular side. So on the running tool, and this is just another shot of it with the sleeve shifted up. So I talked about those lock dogs. So when we drop that ball into that first seat and that sleeve shifts up, it releases those lock dogs, and now it allows the float nut to engage on the running tool. So now we might have been rotating to the right, pushing banging and rotating, but the tool's locked. Once we unlock the tool when we drop the ball, now if we turn to the right, we're going to release the tool. So when we get to depth, we shift that sleeve up by dropping the ball.
Don't do that too soon.
No, you definitely do not want to do that.
That was said with some authority right there.
Yeah, you definitely do not want to drop the ball till you know you're at the depth you want to be. And then the last little thing that we have on this tool is what we call a secondary release. A lot of people like to call it an emergency release. You don't ever want to say emergency unless you have to. So we call it a secondary release pin. But basically, if you can't pump, you can't get a ball to the seat, you got some kind of wellbore problems where you can't get a ball down, you can turn this system to the left, and there's a set of shear screws there that will release the sleeve and allow it to move up. Now we can turn to the right and release the tool off. So it's just a backup method in case you can't get a ball to bottom. So very standard. We don't do that a lot. So
I would hope not.
Yeah. No, we don't. There's times where they have well conditions. They got a leak. They get losing fluid. They can't get returns, and you might have to manipulate the pipe to the left. In drilling world, we always turn to the right, right?
Yeah, correct.
So this is just an internal a view of the running tool. So you can see the upper ball seat there, and that's the extrudable seat. So the ball is going to come down, land in that seat. It's going to shift that sleeve up and release those locking dogs, which allows us to engage on the running tool. So the seats are extrudable. We test them, very, very reliable. They work the same every single time. So the last part of the running tool is our swab cup assembly that goes on the very bottom of the running tool. And typically when that running tool is stabbed up into the liner hanger, we're about, 26, 28 feet long, depending on the PBR length. But out the bottom, we'll have a pup joint on there, and these swab cups will be in that pup joint. So what happens when we get to depth and we're ready, we drop our ball and it unlocks the tool, then it goes to the second seat, which is about 6 feet below. It'll land on that seat, we'll pressure up, and you got a little ported sub here on the top. So what we've done now is we've created a pressure isolation between the running tool and the liner hanger. So as we pressure up, we hydraulically set that hanger. So the swab cups are isolating on the annular, the ball seats isolating on the tubular. We pressure up about 2,200 PSI, and that hanger fires off and sets. So pretty simple in the math on how this works. And then what we'll do once we're set, we'll pressure on up, and the bottom seat's extrudable. We'll blow that ball out, and the ball goes down hole. Now, a lot of people go, well, what happens to the ball? So under our landing collar, we've got a ball catch system that catches that ball so that it doesn't get tangled up in the float system. So once we pump the ball out, we're not worried about it. So that's basically how this system works. I know I kind of stayed high level. And this is just another internal picture of the high pressure ball seat and the swab cup assembly. So I just talked about how we create that isolation. So back to our layout drawing, and I would love to have an animation that I could show you guys, but we didn't get it loaded right. And we could show you how the tools manipulate going downhole. It's pretty neat, but we didn't have that. So again, it's a hydraulically set, mechanically released tool. And we run these things every day. It's a great saving to the operators. That's our value. A lot of people in days past have had, fear of liner hangers because it's a pretty complicated system. But when you break it down and keep it simple and performance, these things are great. They save the operators lots and lots of money. They work efficiently. And, these tools have been around a long time. We've had these tools for a while, but Baker, Halliburton, Weatherford, everybody's got a liner hanger that's very proven system that has always been around for a long time. But as I mentioned before, you're only as good as your service hands. So these guys deploying these tools, there is so many hydraulic and torque and drag, tube moves, hydraulic, things going on downhole that they have to understand and be very well versed in. So, and also quality, right? When we make these tools up, everything is tested. We fire every liner hanger off in the shop before we send it out. So quality, QA, QC is very important as well. So we think we do a good job at that. But hopefully I helped enlighten people a little bit on what a production liner hanger looks like.
Yeah, I mean, I'm definitely learning way more than I'm going to retain at this point in time. So I know we've got a handful of questions. Is this the last?
Yeah.
That's
This is the
slide.
last slide, so we can jump to some questions.
All right. Well, let me.
You wanna switch now?
I'll switch back spots with you here. So we'll jump back over to this camera view, and then we'll do. Oops. Let's just do. Nope. Just take that one off. There we go. All right. So we've got a handful of questions that have come in. So guys, thank you guys for the questions. Really appreciate this. I'm going to ask one real quick. How important is the ID on the liner hanger assembly itself? Like once, when you're the one that's, the portion of it that's being left in whole, right?
Right.
How important is that ID to the client? And like, as far as the specifications of the tool that you run?
Yeah, very important. So the ID should always be really close, if not drift to the production casing. So you want that ID to be the same. You don't want restrictions in there, right? So when they're pumping plugs down, it's the same. It's a smooth bore all the way through. There's no step changes in the ID. So it's very important whether it's a 4.5 system, 5.5 system, a 7-inch system. It's very important that you don't have restrictions. So that's a great question. So these tools have to have that full ID.
So that design criteria means that you have to be able to create all of this functionality within
A very small
the ID
cross section,
or the ID of what the next casing section is going to be, and the ID of the prior casing section. So you've got like,
that's right.
Oh, wrong camera. Okay, camera's back off. Okay, hold on. Come on.
It's got a mind of its own.
Can you switch that one out, please, sir? All right, we'll just have to do this. So, as I was saying, you've got a very, very small, like, I don't even want to say window. You've just got like a slither of room to be able to design and engineer all of this.
That's right. So where, and then when these wells are being stimulated, that might be at 10,000 PSI frac pressures. So that cylinder on the bottom of the hanger is, you've got a very, very small cross-sectional area. So it has to be able to take that load and not, its burst and collapse is huge, right? You got to be able to prove that you can handle those loads. So our tools go up to 15,000 PSI, which puts us in a pretty elite league. There's only, I can count on one hand how many people can do 15,000 PSI. So that's really important that the tools can perform during the stimulation process.
Hold on just a second, guys. I'm going to do some do a little bit of makeshift here as well. There we go. Let's put that on video. Actually, it's to photo. Boop. There we go. Video. We'll turn that one around. Then we can do. Oh, come on. That's not the way.
Why is it crooked?
Why does it want to do that? Here, maybe we'll try it like that. See, this is troubleshooting in the field as we go. Let's see. Really? That's not what we're trying to accomplish. Why would it do that to me? Let's try. We'll try to unplug it. Guys, I promise we'll get to your questions here in just a second. Let me see if I can get this. Maybe if I put it on photo. Is it working? Oh, GoPro's booting back up. No media. You got to take the XD card out of it, or the SD card, if there's one in it. We'll try it one more time with this. Go to camera number 4. Come on, we can do it. That's right.
There you go.
There we go. We'll just do this for a second. Welcome to the Vidor Locksmith Show, guys. All right. So let's see. We've had a couple of questions. All right, here. So we got Eric asked a question. Different liner hanger when a tieback is planned. In that case, why this setup?
So I think, Eric, what you're asking is the different links on the tieback. And by the way, a tieback in a PBR, a tieback sleeve or a polished board receptacle is the same thing. It's just got a different name. So some people call them tiebacks, some people call them PBRs. But if you're talking about the different links, so before the well is drilled, we typically will go through and do a torque and drag program. We will do a tube move, and we will look at how much, in the worst case scenario, when they shut that well in and when they start producing the well and the temperature changes, how much movement we have in the pipe, and that helps us. This helps the operator decide what length of PBR they run. Okay. So I hope that answered your question.
All right, we'll set you on that camera just for a second. We got one more adjustment to make to this one. Stabilization off. There we go. Oh crap, those drop down. If you get those for me, please, sir. There we go. All right. So Eric, thank you for the question. Damon did, I think, just jump in there and try to answer that one as well. Mr. Amer says, is this rotatable? I know you did answer this during the process, but I mean, we can still.
But there can be some confusion there because there's two types of rotation. So when you're rotating while you're deploying the system, and yes, it can be rotated up to 10,000.
Now we're working.
There we go. Up to 10,000 foot-pounds of torque while you're deploying the system down. The other rotational capability is, can you rotate while cementing? So a lot of, not a lot, but a few operators out there like to be able to turn their pipe while they're pumping the cement around because they feel like they get air pockets or isolation in between the pipe and the formation. So if you're turning the pipe while you're putting the cement in, it theoretically gets rid of that. So that's the second type of rotation. And yes, we can rotate while deploying and we can rotate while cementing if needed. I will say that very few people onshore rotate while cementing.
There we go. So Robert asked, do you use a hydraulic set and mechanical release in deviated wells? What would be recommendation?
Oh, absolutely. So hydraulic set, we run in deviated wells all the time. You can set these tools vertically, which a lot of operators set vertically, but here's the key. When they're planning these wells and they know at some point the well's going to deplete and they're going to put it on artificial lift, right? So they want to try to get that hanger as far down in the bottom because they want to get those pumps down as deep as they can go to get the artificial lift, whether it be an ESP or just a pump style system. So we do set out a lot of times in like 60 degrees in a curve. We can set out 90 degrees if we have to. But I will say the majority of these systems are set vertically or near vertical.
Okay.
And you would run a hydraulic set mechanical release in any of those applications. You can run hydraulic set, hydraulic release, but the hydraulic set mechanical release will work in any type of deviated well. Now, if you get into some S curves, and he may be asking about Alaska, where you have they drill these vertical wells, what they call S curves, then you have to have a special tool called a pusher tool to actually get weight down to set the packer. So great question.
All right. I think Sean's in there answering questions too. Sean on your team?
No, but I've known him for a long time.
Oh, okay. I mean, sometimes people jump in there and, no worries. Damon's in there as well, jumping in on some of the stuff. Jerry asks, so the Allamon Permian Basin hanger is designed for high horizontal stimulation burst pressures and lower production flow rate pressures. Is most of the Allamon business in the Permian?
So
Allamon, sorry.
Yeah, no, that's fine. No, so we do have the bulk of our work is in the Permian Basin. We do a lot of New Mexico work. We do a lot on the Texas side as well. We do a lot of South Louisiana work. We do some inland barge work, and we are hunting the Bakken work. We did Bakken work in the past, and we're ramping up there as well. But yeah, the bulk would be in the Permian Basin.
All right. Do you record the setting signature, pressures, and weights to confirm correct sequence and valves to properly set the hanger?
Absolutely. So every time that we set that our tool hand records all that, but they're recording that on the Payson. So the rig's recording all that data. So if there's any issue or problems, we've got that data and we can go back and look at it. But I will tell you that our tool hands have a sheet and they record that data every time on every job.
So here's an interesting question, and I think John will probably be, I think it's a great follow-up question to John's, and he'll probably want to jump in on this as well. So most EDR systems like Payson or Totco only record at 1 second intervals.
Yes.
So with something like this that is so like, I mean, you know, I don't want to say like micro in the actuation and stuff, but you know, you're talking about only moving so much in the span of a 20,000 foot well, right? If you're moving only 6 feet, you know, that, you know,
or a shear that happens like that.
Yeah.
Right?
So would it be beneficial for y'all in confirming that signature to be able to have higher data density to be able to look at that?
Absolutely. Our engineer would be jumping up and down right now because sometimes when you're trying to go back and look at that data, you're right. You're only recording in those 1 second. Well, sometimes a ball hitting a seat can happen in a fraction of a second. So we do things like we don't like to we let our balls fall, and because we want to make sure that we don't see that, you know, we don't blow through that signature. But absolutely, I would love to see that data be in like, you know, way more per second so that we can see some of those events that happen. Not very often do we get down to that point, but I have seen that before when we're trying to look for an event and it's only capturing 1 second at a time and we might have missed it somewhere. So that's a really great question. I love to see that. And I know the technology is driving us towards that.
I know on the drilling side, it's definitely an issue. But it also becomes like when we look at it on the drilling side, you know, you're looking at days of drilling data, and then you know, trying to like
hone in on that,
tune down on something that's, you know, might be. But for y'all, like the scope of your work, it could be just like a 30-second time span, and you know, it's like okay, so if we're at, you know, we're doing 50 samples a second now, then you can really be able to tune in and be able to see that.
We would love that, because when we do have an issue, and they do happen sometimes, it's just part of the business. But when you do have an issue and you looking for something very minute that happened in there, it's really nice to be able to see that. But I understand the downside of that is the amount of data that's being collected is just ginormous, right? When you're collecting so many times a second. So
yeah, okay. Robert Damon, he's asking, so any of the liner hanger systems that were run in salt wells uncemented, how that worked?
So another great question. So one other thing, you know, we were talking about production style hangers, but we also do saltwater disposal type hangers. And these are usually bigger, like 7 5/8 by 9 5/8, 8 5/8, 10 3/4, the big iron systems. And they can be done open hole. However, the majority of those tend to be cemented, but I have seen a time or two where they ran packers and isolate and do different things in open hole. And one thing that we see too, the saltwater disposal with the regulations is an ever evolving system. So it's something that we have to have because they have to be able to dispose of that produced water. And in Texas, it's the Railroad Commission, but in other states, they're really honing in on the pressures that we can inject back into. So it's an evolving process. I will say most of those wells are cemented up, but I have seen a couple of times that they did some alternate style completions that they didn't use cement.
All right. Mr. Amer says, what if do not get the pressure indication when you drop the ball?
So that's a bad thing, right? So if we're not seeing any pressure, we can't hydraulically set the hanger. So we have some secondary and tertiary capabilities. So we can do a couple of things. We can drop another ball that's a little bit larger to catch that seat. We also have a ball we can drop that can go down onto the landing collar, and we can set the hanger from the very bottom of the well instead of in the running tool. So in the old days, everybody set their hangers off the bottom. So you had to pump a ball all the way to the toe of the well. And when it got on the toe of the well, it would land on a seat, and then you pressure up the whole system to hydraulically set the hanger. Obviously, nowadays with these incredibly long laterals and measure depth wells, that's not efficient, right? It takes a long time to get that ball to seat, but it is a secondary or a tertiary way of setting. So we have backup methods if we can't get pressure. So if you're leaking off so bad that you can't pump or you can't get anything to set the hanger, the good thing is you can just pull the system out because it's not set. Even if we set the hanger and they have a problem, we can still pull up. We can still pull because the slips are holding down. So if we needed to come out of the hole because I had something bad going on, then we can do that. Once you set that packer, though, you're there. So once the packer set, it's what we call permanent, right? So it's not coming
at that point.
Yeah, it's you're done at that point. You're not going to be able to retrieve it.
Yeah. Okay. There's just a couple of comments there from Damon. So I know Damon's with the team, so I'm not too worried about him asking questions unless he's asking for a raise. Do you ever run a latch seal assembly?
Yes. So great question. So we talked about the PBRs and the floating seals. So one really cool factor that we have in the Allamon hanger is that we have a latch profile inside the hanger, and most other companies have a latch profile in the PBR where you got a really thin cross section, so you can't handle a lot of tube move with the pressures or with the forces. But in our tool, we have a profile inside the mandrel. So we can actually run in, we have a latch, and you can latch into that system. And then instead of having floating seals, now you're latched. And so we'll run a torque and drag, or not a torque and drag, but a tube move to see what those forces look like. Where that is an advantage is the Bakken. So the Bakken is typically, you have about 16 foot of tube move. So you got to run a 20-foot PBR. That's expensive, right? So with a latch, you can run that latch in and you can run a 10-foot PBR on top, which is a cost savings. And that just gives you a secondary if you ever wanted to float seals. But you can latch in, we can handle the forces of the tube move during shut-in and production, and a shorter PBR. So that's the advantage of the latch system. Very funny, David. A lot of people are scared if they float. They don't like to change the latch. So for me, I always thought that was a really cool option. But sometimes when you're anchoring or latching, it scares, if their program is to float, they're good with that, right? They know they're not going to part pipe. So a little bit harder of a sell of people understanding the latch versus the floating seals.
I mean, change is hard.
Change is hard sometimes. All right. Definitely so.
Tully Rowe, he's just jumping in there. I think Damon's asking, or Jerry's asking, is the majority of your sales in the Permian horizontal market? I think you already talked about that one a little bit. All right. I think that's it for all of the questions then. So we've got caught up there. I've got another just random question because this is something that came up at one of the recent events I was at, and they were talking about when they were setting cement or when they're pumping their cement, that if they have an influx or the well kicks, and then they get separation on the backside of the casing because you get something that's coming in. How would your guys respond in a situation like that? Like, where does the liner hanger tool hand, like, where does he come into that? Is that more on the cementing guy, or is that like everybody gets together and goes, okay, my tool can do this? Cementing guy, you do this, we do this. How do we solve that issue?
That would definitely be one of those. If the well's trying to kick while you're cementing, you're getting an air bubble in there or gas bubble coming up. That is pretty much all hands on deck. We are out there as a service hand to deploy our tool, and in the line of it, we can make suggestions of what we do. We can talk about our tool capabilities, but when you have a well condition like that, typically the company man is going to make that call on what we do next. So, but we always are giving that advice and that recommendation. But if you were having a kick during something like that, that would be an all hands on deck. Decide if they want to just stop, shut the well in. What do they want to do to maintain well control? So that would be, typically we don't see that. Most of these formations, the operators are very familiar with them, but sometimes you get into a zone that just will surprise you. So yes, you're exactly right. It would be all hands on deck.
Okay.
It's a great question
because when something like that happens, it's like, what else can be done? Who else is there? And, it's obviously a situation on that side of the business. Like, we've seen well control issues on drilling side, right? But like during the cementing and casing stuff, off elsewhere.
Well,
So just to be able to understand the dynamic of people be able to come in and say,
Yeah.
you know, hey, our tool can help do this, or, you know, now it's like, nope, pulling out a hole, we're gonna
go to flush, try to get it out of the drill pipe. You know, if your well's trying to flow on you, you're gonna make those quick decisions. You can't just stop and think about it. So a lot of times that's going to be on the operator of the company man side call, with our guy standing there saying, hey, can we flush this out? What do we need to do? If it got really bad, do you shut in your hydro, you know, whatever. But cement's pretty unforgiving, so you want to try to get it cleaned up best you can. So I have not seen that. I have seen some nasty kicks, but not in a situation in a Permian or Bakken or DJ or you know, any of the Oklahoma stack scoop stuff. I have never seen one kick like that where we had to shut in. So, but that doesn't mean I'm still always learning, seeing new things all the time. So.
Yeah, same here. Well, Travis, thank you so much for coming on to the show, man. I really do appreciate it. Any last words, anything you want to say to everybody watching?
Oh, no, appreciate the support from my team there. They're firing off questions there. Thank you, guys. David, thank you for having me. It was a joy. Enjoy getting to share some knowledge with these guys.
All right. Well, guys, thank you all so much for tuning in this Friday. It's been an absolutely amazing show. I know I've learned a lot. I'm going to probably have to go back and watch this episode 2 or 3 more times just to be able to let this all soak in, because there is so much here to be able to unpack. I'm really just being able to try to be able to bring for you guys out there all the different aspects of what we're doing in our industry. It's not just drilling. There's a lot that takes place when, you know, we're not at the rig, or at least not on the rig floor. So if you guys have any suggestions for maybe other people that we can bring on to the show in the future, please let me know. Next week, we're going to be doing some fluid stuff, some drilling fluid stuff. So we've got Amer from New Park. He's going to be coming on talking about drilling fluid myths, right? The week after that will be with Kenny Baker and Mike Holcomb. Kenny Baker from Cactus, Mike Holcomb from Patterson, the new generation of floor hands. We will be we'll be streaming live from Patterson's rig up yard, potentially on the rig floor of one of their new rigs. So that'll be a first time ever to be able to do an interview right there on the rig floor. Actually, no, we've done one before. It was the 360 live stream, but the way that we're going to be doing the show to be a little bit different than what we've done in the past. Still something new. Be sure to tune in on Tuesday for the Torque and Drag mini series. Like I said, episode number 4 with Dr. Stefan Manon, soft versus stiff string models. That episode is brought to you by D-Tech. All right, guys, that's it for me this week. Oh, wait, we didn't give away the drill bit. Hold on. Present. I almost forgot. Stop screen. Present. Share screen. Chrome tab. StreamYard giveaway. There we go. 24 entries. There we go. It's running at the stream, and the lucky winner this week is Oscar Morales. Oscar, get in touch with me, please, sir. We will get you a drill bit. Thank you so much. See, we'll get you a drill bit. Matches my my sweater today. All right, Oscar, thanks for tuning in and watching the show. Do appreciate it. Do appreciate everybody who watches. Keep looking at the wrong spot. Camera's up there. All right, that's it for me this week. Tune in on Tuesday. Tune in next Friday. As I always say, know your industry.